Strategy Management Series. Video number 111 Strategy Formulation. Step 7 Strategy Evaluation. Game Theory Nash Equilibrium. Welcome back to the Ready MBA series on strategy management. In our previous sessions, we delved into strategy evaluation, the crucial seventh step of the strategy formulation process. This stage entails scrutinizing potential strategies for their impact, benefits, costs, and resource requirements. We also discussed game theory, a technique for predicting competitors' moves in a competitive situation, and how it can be leveraged by the planning team to refine their strategic analysis. One of the primary benefits of game theory is its ability to help decision-makers anticipate the potential outcomes of different strategies and understand the ripple effects of their choices. This is especially valuable during strategy formulation and evaluation, as it allows planners to simulate various scenarios and assess the best course of action. We introduced the concept of simultaneous moves games, where players make decisions at the same time and without knowledge of others' moves. These games often involve creating a strategy that considers all possible outcomes based on the actions taken by each player. To find the optimal strategy, planners need a dominant strategy that consistently provides a better or equal outcome than all other strategies, regardless of what the opponent does. When both players have clear dominant strategies, the combination where they intersect in the payoff table becomes the likely outcome. In some games, however, there are no dominant strategies that are always the best regardless of what the other player does. Instead, players must consider the potential choices of others and then determine their best response. This is where Nash Equilibrium comes in. A Nash equilibrium is a concept in game theory where each player's strategy is the best response to the other player's strategy. In other words, once in a Nash equilibrium, no player has an incentive to change their strategy, as doing so would not improve their outcome. This equilibrium can be a powerful tool for understanding the optimal strategies in competitive situations. Let's consider one example to illustrate Nash equilibrium: the gas station game. Imagine you and a competitor own gas stations across the street. You both need to decide whether to set your prices high or low. In this game, there will be no clear dominant strategy and the best outcome will be defined through Nash equilibrium. Let's see the reasons for that. If you set your price high, and your competitor does the same, you'll both earn more profit. Both will cater to a smaller customer base, but with higher margins. However, if your competitor sets a low price while you keep your prices high, you'll lose customers and profits. Your competitor, in turn, will increase profits, as they attract a larger customer base that compensates for lower prices. But if your competitor sets a high price, you'll attract all the customers, maximizing profit with a low price. If both gas stations set low prices, both will get moderate profits. Although the customer base will increase for both, the lower prices will impact profits. In this situation, there is not a single strategy that maximizes profits for either player independently of the other's actions. It highlights the importance of considering your opponent's potential moves before deciding on your own. The way to solve this game and to find the best strategy is through a Nash equilibrium. A Nash equilibrium is a set of strategies, one for each player, where no player has an incentive to change their strategy given the strategy chosen by the other player. It's a point of stable decision-making. Let's analyze the gas station game using a payoff matrix to make it easier to be visualized. If you and your competitor set high prices, both will earn high profits. Conversely, if both set low prices, both will earn moderate profits. If you set high prices, but your competitor sets low prices, you will earn low profits and your competitor will have high profits. And if you go for low prices, but your competitor goes for high prices, you will get high profits and your competitor will get low profits. Here's how the planning team, representing your gas station, should think this game strategically. 1. Eliminate dominated strategies. Are there any options you would never choose regardless of your competitor's move? In this case, there are none. Both high and low prices have situations where they outperform the other. 2. Best response analysis. Look at each cell of the matrix and ask yourself, if my competitor chooses X, high or low price, what is my best response, high or low price? For example, if you see your competitor sets a high price, your best response is also to set a high price, resulting in high profits for both. Analyze all other cells in this manner. To find the Nash equilibrium, we need to identify the cells where both players' best responses coincide. If you choose low prices expecting high profits, your competitor will do the same, and both will end up worse off by having only moderate profits. However, this is another stable point in this game, where none of the players has an incentive to change their strategy. This is another Nash equilibrium. In this game, we have two Nash equilibria. One lies in the top left cell where both stations choose high prices, and the other in the bottom right where both choose low prices. An equilibrium does not always imply the best outcome for the players. Equilibrium means the best response of one player to the strategy chosen by the other. In this example, even though low prices are an equilibrium for the two players, it is not the best outcome. The best outcome could be achieved if both players coordinated to choose high prices. Now let's consider a second example, a modified gas station game with a different competitive situation and payoff matrix to illustrate a case with more than one equilibria. In this game, if you and your competitor set high prices, you will earn high profits, but the other player will earn low profits. This is a different payoff from the original example. If you set high prices, but your competitor sets low prices, you will earn low profits and they will have high profits. Also differently from the other example, if you go for low prices, but the other competitor goes for high prices, you will get low profits and they will get high profits. Last but not least, if both players choose low prices, you and your competitor will earn moderate profits. Now, performing the same analysis for this game. We can see that neither player has a dominated strategy, as there is no single strategy that is uniformly worse than the others. Setting a high price can be profitable if the competitor also sets a high price, and setting a low price can be profitable if the competitor sets a high price. In other words, there's no single always bad option. Next, let's proceed to the best response analysis. If you set a high price, the competitor's best response is to set a low price, maximizing their profit by attracting customers. If you set a low price, the competitor's best response is to set a high price, maximizing their profit by catering to a smaller customer base with higher margins. There are two Nash equilibria in this scenario. Two situations in which the players have no incentives to change their strategies considering the other player's response. Equilibrium number 1. You set high price, but your competitor chooses low price. This strategy is attractive for your competitor because they can undercut you with a low price, attracting most customers and leaving you with low profits. This is a potentially risky outcome for you. Equilibrium number 2. You choose low price, but your competitor goes with high price. You set a low price to attract customers, but the competitor takes advantage by setting a high price, maximizing their profit with a smaller customer base. This is a potentially risky outcome for you as well. Key takeaways. The modified gas station game demonstrates that a Nash equilibrium doesn't always lead to an ideal outcome for either player. In this case, both Nash equilibria result in one player getting significantly lower profits than the other. This highlights the importance of considering alternative strategies like cooperation, which might not be captured by a Nash equilibrium analysis but could lead to a win-win situation for both stations. When to look for Nash equilibria. Planning teams should consider Nash equilibria when 1. Strategic interdependence exists. Your success hinges on the decisions of your competitors, meaning no dominant or dominated strategies in the game. 2. Multiple strategies exist. There's no single dominant option for each player. 3. Focus is on stability. You want to predict and understand the likely outcome of a strategic interaction. Benefits and pitfalls. Nash equilibrium helps predict stable outcomes and identify potential strategic moves. However, it doesn't guarantee the best possible outcome for either player. There might be situations where cooperation through communication could lead to a better outcome for both, but such possibilities fall outside the scope of a Nash equilibrium analysis. By understanding Nash equilibrium, planning teams can navigate the complexities of strategic decision-making, considering the potential moves of their competitors and arriving at stable, predictable outcomes. However, it's crucial to remember that it's just one tool in the strategic arsenal, and other factors like potential for cooperation should also be considered. And this concludes our episode about Nash equilibrium and how to use it to identify optimal strategies. Please join us in our next episode where we will continue our discussion about game theory. Until then, keep strategizing. See you soon.